Hello, Data Voyagers. This video, it's an addition to an article that I published the same day this video is being published on our blog, Data Voyagers. So go to Data Voyagers so you can access here. There's the logo, datavoyagers.net, and find my articles about transforming audio and video files for Qlik Answers. So in a nutshell, what we're trying to accomplish here is basically to allow Qlik Answers to be able to learn from audio and video files. We're using video files, but the same technique could be applied to audio. Audio is actually simpler because then we're skipping a few steps. I'm not showing the Qlik Answers part because that's the easy part. I'm showing just how we make video data and we convert that to textual data. And then Qlik Answers, you can check my article to understand that piece. So if you're watching this on YouTube, then check the description of the video and you find the link to the article there. All right, having said that, let me share my screen and let me describe this scenario that I'm implementing. So I have a list of video, and this is a real implementation. So these videos are actually things we use in the company. We use an IPC. We have this initiative in our educational department called the expert session. So every 2 weeks or so, we have an expert in a certain area come and do like a webinar, and we'll record those webinars, and we have a learning platform where people can watch those to get credit for it. However, I want an Qlik Answers assistant where I can ask questions about the content presented and people can get answers. Like we have like great content here, like time series, for example, or set analysis, or a lot of things, most Qlik related. Great, but these are video files. These are MP4 that we store in an S3 bucket. How can I then fit Qlik Answers with those? So if you open the knowledge base, you'll find that we have many different file types, unstructured data file types, like HTML, PDF, Markdown, etc. However, MP4, MP3, WAV, those media files are not one of those options. So there's a solution that I came up with. Again, read the article to have an idea of the whole solution. I'm showing the piece that actually makes the transformation, which I wrote in Python. That's something that is outside of the scope of Qlik. So I wrote it in Python, but it is all automated and it's scheduled to run like every week. And so it's all automated. So let me show my Python notebook. So let me minimize this. So there's a Python script. It's actually running. I'm not going over every single little detail explaining how to program these pieces. It's not a Python training. I'm just going over the overall techniques. So basically, these are the libraries that I'm using. Some of the libraries I'm actually no longer using. I was just use them for a little bit of testing. But overall, these are the libraries that I use. So you see there's a plenty of libraries for a lot of the things that we are doing. And then so I started by creating a few functions. So I created a function just to read the content of text file. This is just for preparing the environment. So my AWS S3 bucket information, I'm not, of course, hard coding that into my script. I have them in a text file. So this function basically read the content of the text file. I have this for future implementation. Right now, my code supports only English. For future implementation, I'll detect the language and use that in order to extract the text information. And then I have two functions to actually do like the heavy lifting, the actual work. I have one, and if you read the article, you know why I have two functions. So basically, I have one that's my default one. And the name says it all, extract text from audio. So I get a video file, I convert to an audio file, I save the audio file as a WAV file. But then if the file is too long, sometimes you get an error. Not all the time, depending on your availability of CPU and memory. So it's not totally random, but it's kind of unpredictable if the file is too big. The way I solved this issue was by simply splitting the file into small chunks. And I decided to split, and the unit of measures in milliseconds. I decided to split this into 30 seconds. So each 30 seconds creates a chunk. So I have a function here called make chunks. I did not create this function. It's part of the libraries that I imported. So then I process the chunk. So that over here, I'm doing a loop. And through the loop, I'm actually extracting the text information from the audio and then returning that as a variable. How I'm doing it? So this first way, I'm using a Google AI library, so Google Speech Recognition Library. So that's the function that I'm using. I'm using this library called Recognizer, and I'm using this Recognize Google function. Pretty simple. All right. I have another way, but this requires the audio information, audio data to be sent to the Google Cloud, to some cloud. So some customers, they might not want that. So then I have another option, which is runs locally. For that, I'm using, and I describe that into the article, but I'm actually downloading. I download a neural network for this task for audio and speech recognition, audio recognition, and I basically save on my computer, and so that's what I'm doing. So over here, I have all in the article. I explained that into more details. So for here, I do a little preparation. I have to do something else for this library. I have to convert the audio to mono 16 hertz frequency. So that will simplify the audio file. That will make easier for this neural network. So I mean, I'm using also, there's another thing you need to install is the FFmpeg library. So I'll put the links on the description of the video. So you install that. You need to install that in order for this to work. There's a little bit more work to do the local thing. And then basically, I'm using the subprocess library. It's a very popular library in Python to actually process this. And then once I have this process, I have the text extracted. And then at the end, I return that. All right. All right. So then that's the local, and that's more details to this, but I think will be a too long video if I explain every single detail. But that's basically what I do. I have another function here that is basically, I'm just clean up some WAV files. So basically, I get the video file in my solution. I extract the audio, save the audio as a WAV, and that's my source for the speech recognition. After everything is done, I don't need those WAV anymore, so I just delete them and clean up. So I just loop through all of them and delete them. So this just function yet. I've just created a function that I'll call later. Then we'll have now some data preparation. So basically, I'm defining where I'll store my videos locally, where I'll store my transcripts, the actual text locally. If those directories do not exist, I'll create them. And then this is the key. This is a flag that defines which of the two solutions for transcription I'm using, the remote one that uses Google or the local one. So in that case, which uses Vox, that's the local library that I'm using. In this particular case, you see that I'm running remote, but so it depends on each case. I'm running remote because it's faster, but people might decide to run local for data privacy reasons. Then this is all AWS stuff. I'm connecting to my bucket. The authentication in this case, I save the AWS security key and the secret key as local system variables, as local environment variables. So that's why then you will automatically connect through my user. So I'm connecting to I'm creating an S3 client. This transcribe client I've tried to do through the S3 bucket. There's another way you can run the transcription in S3 bucket. There'll be a third way. but I'm not implemented yet, maybe in the future. And then basically I'm listing all of the videos or all of the files in that case in that bucket. So the bucket that you saw earlier, that function basically lists all of the files here. So then I will process them, I'll loop them and process them. And then basically I'll do the magic. I'll start by this function here basically creates an array, a collection of all of those files. So now I have this MP4 files as a collection. Then this is just functions to calculate, the class that I might use to calculate like the percentage, how many I ran, etc. Just for some user interface kind of things. And then now everything that I show so far is just preparation. Now is actually the process. So first thing I do, I loop through all of the files and I check if the file exists in my local drive, then I do nothing. If the file does not exist in my local drive, then I will download the file. So I'll download the file to my local drive. So I'm processing the files locally. You might decide to process in S3, but then you might be careful, or Azure or other cloud platform. But if that happens, be careful, because you might end up paying for extra processing costs, AWS processing costs. So I decided to download. I'm just printing the results here. If the file was downloaded already, I just print a message. I'm skipping download. That makes it so much faster, because then you don't download a file that you already downloaded. And then is the actual work of transcription. So I have two functions. If it is remote, then I'm doing this. I'm calling the first function that uses Google. And then at the end of the day, I will save a text file. I save a text file, but there are many possible files format for this. You might decide on doing PDF or Markdown or HTML, Word document, etc. Text file, like one of the simplest. So that's why I decided for that way. And also smaller files. Then we have the alternative way using Vox, as I mentioned before. So that's for the local processing. So is that my variable is local, then it will process this. I will clean up the result, basically cleaning up all of the WAV files. And then at the end of the process, I'm basically uploading the files, transcription files, the text files, back to an S3 bucket. So if I go back to the S3 bucket, let me open there. Then if I go up a level here, I have all the transcription files as text files. So all of these work. I basically read video files. I could read, if I decided to, instead of video files, it could be simply audio files directly. But basically, read audio files, I read them, convert whatever text is being spoken to a text, and then save the text in a file and upload it back. Now, in QlikAnswers, your knowledge base needs to have access to this transcription. So in my implementation, I've created a data connection to this S3 bucket. And then inside the knowledge base, you can create an indexing scheduling. So then I scheduling, in this case, to reload every day. So if there's new files here, then we'll have a new file index, or any change in a file, which in my implementation it would not have, because the video, once it's published, is not edited, is not changed. So I don't need to worry about that. It's just additions. So that's how I'm implementing this. So then you can go to QlikAnswers, and then you can get your answers based on video files answers. So it's not a direct solution, because again, we can make the impossible possible to a certain limit. QlikAnswers do not allow yet directly feeding data or learning from video or audio. So then we did this workaround then to convert audio or video to formats that it can accept. Okay. Again, read the article that I wrote about it, so you can have an idea about the whole implementation. I hope you like this. If you did, please make sure to subscribe to our YouTube channel, share this video and the article to everybody you think you might be interested into this. And see you next time. Keep exploring. Goodbye.